All right, good morning. We're going to do, or whenever you're watching this, I've given you information for lesson 18, days 1 and 2. I've expected you to go through the story problems, the problem sets, everything that's there. I think if I'm going to address this, I've given you notes up through day 3. So I'm going to finish out the lesson, talking about day 4, working through it. Go ahead and work through with me on this one, and again, skip to find the new material, or just go through it as I go through it too. The expression 5 times 1.15 to the power of t gives the area in square meters damaged by a fire as a function of minutes, so that's our t, since the fire was discovered. 5, because it's that number that's at the beginning, we've talked about that being the initial value, or the y-intercept. That's what it physically is. However, what we need to be able to do is to determine or state that this means there were 5 square meters of area damaged by a fire. Initially. I guess I'll say that word. I say when the fire began, or when we started counting with this model. But I'm going to say, abbreviate it to say initially. The 1.15 means that the fire is spreading by 15% every minute. And I get that 15% because 1.15 is the same as 115%. And 115% means that you will have the whole amount of what you had a minute ago, but you've added to it 100% plus 15%. You've added to it 15%, so it's bigger and bigger and bigger every minute as things grow and the fire spreads. So to evaluate the function, t equals 4 for in context, literally just take the 5 times 1.15 and raise it to the power of 4. And if my calculator will turn on quickly, I'll tell you what that is. Not that one. I'm going to use 89. It's dead. This is my life. And this one will take a million years to turn on. I'm going to get a pen while that does that. Go ahead and skip ahead. Wow. Never seen that before. Okay. Let me just jump out of this, pop up a new tab. Let's go 5 times 1.15 to the power of 4. Oh, look. 8.745. So I'm going to go 3 decimals that way with 3 decimals. Pretty standard math answer. And then add the units of measurement, square meters. Okay. That is the expression. We're in the section of the module where we're talking about the information in context. Okay. Identify the growth factor for each exponential expression. The growth factor is the thing in the parentheses. It's going to multiply by 4, or it's going to double every time, or this thing that is looking at the exponents. The growth factor is the number that's being modified by the exponent. And in this case, the growth factor is negative 1.5. Or for the last one, that is so grainy. Why is that grainy? 2.07. Leave that up there for an extra second. Growth factors. They're the numbers that are in the parentheses. They're the numbers that have an exponent variable. 4, 2, negative 1.5. Negative goes with, and 2.07. I'm going to try to figure this part out. Like, why are you grainy? Sorry I'm putting you through this, but it has to be. Normal. Ooh, some filters. Yellow on black. You know what it is. Okay. No. All right. Well, I don't really want to mess with any settings in the middle of the video, so let's just move on. And you can struggle as you will. Use properties of exponents to change the base of an exponential function. Consider compound interest for when you invest or deposit money in the bank. Here's a formula for compound interest. I mean, just straight off from Google. You Google search this, and you probably even find the site where I pulled this for you. Literally, all we're doing is we're trying to enter or place the information from what's given to us into this formula in order to calculate the amount of money we'll have in the bank. So if the principal is the amount of money that you initially start with, so initial value, and then your growth rate, kind of a tricky thing. Banks can kind of hide your true amount of money that they'll be giving to you if you're not number savvy and don't know how to calculate things real well. The interest rate, write it as a decimal, is R. This is the part that is compounded. To compound means to make more complicated. A compound sentence is where you have multiple clauses that form a complete thought. But sometimes those clauses are themselves complete thoughts. That doesn't matter, don't worry about it. A compound word, all right, a compound word where you put two words together like baseball. Those are two separate words, but together they make a compound word. And so compound means to complicate or to add to something multiple levels of layers of conversation. N and N are repeated twice. And then T is the number of the time in years. Again, I hope you have your paper in front of you because, as I'm looking at my screen, this is super grainy and I don't know if it'll be better. Okay, so using the formula, part A, if P equals $1,000, so A equals replacing P with 1,000. The notation here I'll drop in a minute. R, it's written as a percentage because that's how they write them down for you, but we're going to write it as a decimal. 5% is 0.05. N is determined quarterly, pretty much standard procedure for a bank. They're going to give you a quarterly interest rate. So we're going to make N be 4, so 4 up there. And then if you think about it, in 7 years, the bank is going to calculate your interest 28 times. 4 times 7. And so all of this goes into your calculator. Make sure you use exponents. I'm going to use a different model of calculator because, why not? 1,000 times, we'll clear this out. 1,000 times, and then I'm going to do 1 plus 0.05 divided, nope, didn't do the point, 0.05 divided by 4, okay? Annual interest rate is divided into 4 sections to the power of, and then probably going to use parentheses. I can do this math. 4 times 7, I'm just going to put 28 right there. Okay, calculate. Oh, nice. In 7 years, 5% interest rate, compounded quarterly, you'll have made $415, assuming you never touched that money. So you now have nearly 50% of what you started with. 0.99. We don't need the 3 decimals because, 2, 3, 4, those are not dollars and cents. Okay. R is a tricky number, and the bank financial system can use it to disguise your interest rate per year. So use properties of exponents to calculate the interest rate per year. And what I mean is, let's take this information, calculated whatever. So we're going to do the 4 here. Let's take and the 1,000 doesn't matter. Let's take the 1 plus 0.05 divided by 4 to the power of 4t. We're going to use properties of exponents, kind of what we've discussed in class before, to get t to be by itself. We're looking for something to the power of t. Well, in order to get that something, the first thing that I want to do is I want to do 1 plus 0.05 divided by 4. That gives me, this is my actual quarterly interest rate. I'm getting 1.25%. So I can write this as 1.0125 to the power of 4. And if you have 4 times t, that means that you can further separate the expression so that it's 4, and then that expression is raised to the t value. So if I take this number and I raise it to the 4th power, this is my interest rate. Hey, I guess that matches. 5.09%. I guess I didn't really prove much. But I did want to make sure that I showed this step, boom, 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 that you can take an exponent like 4t and split it into to the power of 4 and then that to the power of t. And then just literally plug in 1.0125 to the power of 4. So I get 1.05 to the power of t. Something fills off. I'll leave it the way it is. Based on the answer to part B, calculate the interest rate per month. Okay, so this number right here, interest rate, and I feel, I'm going to put a question mark here. Like, I need to go review that for a second. So just write it down. Trust that the math I want to show you is this. And then let me go ahead and address, like, yeah, that's wrong, or yeah, I agree with that later on as I reflect on it a little bit more. So LeBrant needs to reflect on this. Okay. Based on your answer to part B, calculate the interest rate per month. So if this is the interest rate per year, then in order to calculate the interest rate per month, I need to know how this works on a month-to-month basis. There are 12 months in 1 year. So if I think about, if I think about taking that exponent and raising it to the power of 12 over 12 t, 12 months per year. So I have to think about how this is currently 1 year, and there are 12 months in a year. So I have to multiply but also divide at the same time. So I'm looking for 1.05, check this out, the power of 1/12, the power of 12t. So it's like I took that fraction that was 12 months is a year, and I added 12 over 12, and then I split the fraction so that 1/12, that's the per month, and then you know what, 12 months in a year, I can just plug in 4 years here and get 48. But this 1/12, I'm going to highlight it, and it's going to be a mess, but I'm going to highlight it. That's the key detail, in that there are 12 months in a year. So I have to raise this to the power of something that messes with that fraction. Calculator comes back, and let's take our answer, let's raise it to the power of, I'm just going to leave the whole decimal. I know that there's fewer decimals here. I'm going to leave the whole decimal. My calculator can handle answer just by using the answer button, A and S. Look for it. On this calculator, it's down there. On this calculator, it's right here. Okay. Raise it to the power of, parentheses, 1/12. Oh, holy cow, that's tiny. So you get 0.4% a month. That's why your money doesn't really grow when it's in the bank. It just maintains. So 1.00415. I'm going to add more decimals because there's so many zeros right there. I don't need to really add them. I kind of do for my answer to the power of 12t. So the interest rate per month, R equals 0.415%. Super small. All right. I mean, that fully addresses a couple of things. Skill-wise, did you know you can take an exponent and split it like this, and then take what's inside and just calculate it, because that's just a number, and then raise it to the power of t? Like that's something you could do. Did you know that you could take a relationship like 12 months to a year and write a fraction of 12 over 12, because that's a year, and then split that fraction to make it look like this? Like, that's the skill that you need to know about, is how you can tease apart the exponent and attribute some of the exponent with the base and keep the variable the way that it is. Well, anyway, exercise 3, extra practice. And you know you don't get points if you don't get it done. I'm going to go to 27. Tim deposits money, a certificate, a CD, certificate of deposit. So this one gets you a little bit more money. The interest rate's a little bit better, like 6%, 7%, although in years past it's gone down. The balance after making the deposit is given by initial value, growth rate to the power of t. So by what percentage does the value of t grow each year? So, you know, this number, 1.06, is 106%, which is 100% the money he started with, plus 6% the amount the bank is adding to it. So therefore, that's your R value. by what percentage does the value grow each year? By what percentage of t does it grow every 2 years? Okay, now we have a problem. And the reason that we have a problem is because this is calculated on a 1-year basis. So we have a t equals 1 up there. What we need to consider then is 1,000. Actually, the 1,000 doesn't even matter. The 1.06 is compounded twice every 2 years. So we can take t and rewrite this as 1.06 to the 1/2 squared t. So that this right here, which part? I'm messing with something. I'm missing something. I got that backwards. Sorry, I know. I'm doing a pen too, so don't complain. 1.06. If I'm talking about every 2 years, that means that I should be able to put a 2 right here and get an answer of 1. All right, I want to have an answer of 1. So I'm going to square this and put the 1/2 t on the outside. The reason is every 2 years, t is still representing years. So if I put a 2 right here, 1.06 squared to the 1/2, I'd still multiply those and they'd cancel, but I'm pulling them apart so I can put a 2 there and I get a 1 answer. And then what's inside is the percentage, that is how much it's going to grow every 2 years. 1.06 squared gives me 1.1236. So 1.1236 to the power of 1/2 t. Put a 2 there, we get an okay acceptable answer, and so therefore we say that 12.36% is our R value. Same reasons as up there. Split this apart and then take the decimal and make the decimal percent. By what percentage does the value of t grow every month? Well, the value of t, once again, every month goes back to what we did on the previous page, where we look for some sort of 12/12 relationship. So 1.06 to the power of 12/12t, and then I'm going to say what goes here and what goes next to the t. Because once you know how to set this up so that you get, 1 year go, blah, 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 then you'll have your answer. That is your R value. But that's extra practice. You need to do that one. Extra practice. Take that. Exercise 5 is extra practice. Remember, take this number, this growth factor, how it has a t. That's in thousands of dollars per year. We want to apply it to months. So split it down. And then I know the summer might make you think about, if it didn't, for some people, it may make you think that there's only 3 months in the summer, so I'm going to do it by 3. Well, maybe you could think about it that way. Or you can think about it as just months is a 12th of the year and not dramatically influence the mathematics that you're doing. Okay, exercise 6 absolutely looks like a test question on the Smarter Balance. The expression 11 times the quantity 1.022 to the power of t models the per capita gross domestic product, GDP. So that's the amount of stuff that we produce and ship overseas or to ourselves in thousands of dollars as a function of the number of years since 1950. So we're just interpreting what these numbers represent. And don't forget, it's in thousands of dollars. Okay, the per capita GDP in the U.S. was 1,022. I mean, I see the 1,022 right there, but that's not an initial value. That's what this is saying. 11,000 is 11,000 is the initial value. So the per capita GDP in the U.S. was 1,022. That's false. The maximum per capita GDP occurred 1.022 years after. No. This is growth factor. It's not a year measurement. It's not a dollar measurement. It is how much more we have. So years, to put years with the growth factor is inherently false. The per capita GDP in the U.S. multiplied by approximately, boom, that's exactly right. Multiplied means growth factor. So we've correctly interpreted that 1.022 each year. Each year is not a measurement of 1.022. This is still unitless because each year is taken care of with the t is years, but the growth factor is not. So false, false, true. Okay, let me see where we are with the lesson. Lesson should be nearly done. A simplified compound interest formula to determine the amount of time is 1 plus r. What is r? Like, just interpretation. What is this? All right, think about it. Look it up if you need to. Can you calculate simple and compound interest? You know what? We actually didn't do any simple interest because in this lesson, because you've been doing simple interest this whole time. A simplified compound interest formula. Boom, there it is. Simple interest. That's like saying every year, just plug in the numbers. No worry about manipulation of the variable, of the exponent. Okay. I know for sure that I've seen this question several times. So please do the exit ticket. Please do the success criteria. Rate yourself. How could you improve? I need more practice. Well done. I figured you'd say that. The problem set is homework. It's, of course, extra practice. Do your best. Do your best work. And you know what? If you want bonus points, I want to see a good report. I'm thinking like I might replace a test grade. Replace a low score test grade. If you do a report on kudzu, trust me, I'll read it. Trust me, if you cheat me, I will find out. But replace the low score test grade, do your best work. I mean, I'd start with Wikipedia and just kind of get some observations there, and then build up to a model. Like you should make a table. You should, you know what? This is not going to be an extension. This is going to be an actual assignment. But I'll talk about it. Okay, there it is. Lesson 18 is completed. Thank you so much. I hope you have a good day. And if you have any questions, be sure to ask. Like and subscribe.